In this video, we will show you how to adjust a Polaris valve with its dedicated adjustment kit. In the adjustment kit, you will find the 3 instruments to perform the adjustment, as well as a quick start guide and a demonstration valve. The first instrument is the locator. It has a flat bottom with a cutout in the center in the shape of the valve. The rotating ring around the perimeter is used to select the pressure setting range of the valve being adjusted. The second instrument is the compass, which allows reliable and accurate direct reading of the pressure setting value of the valve. On top of the compass, you will find a needle to center in the target. Once the compass is centered, the operating pressure reading is determined by the alignment of the needle with one of the lines on the compass and the corresponding pressure value in the reading area of the locator. The third instrument is the magnet, made up of a specific assembly of magnets designed to allow the unlocking of the rotor and the adjustment of the operating pressure of the valve. First, position the patient in a comfortable way that also allows an easy access to the valve implantation site. Next, prepare the locator by selecting the correct pressure range to match the implanted valve. Here, it is the 30 to 200 millimeters of water range. Now, palpate the patient's valve implantation site in order to determine both the location and orientation of the valve. Using the inlet and outlet connectors as guides can be helpful. Place the locator above the valve with its central cutout axis aligned with the valve connectors. Insert the compass into the locator and center the needle shaft in the target by moving the instruments in plane movements. When centered, the needle will indicate the current operating pressure of the valve. In this example, the valve is set at 110 millimeters of water. Next, while keeping the locator in its centered position, remove the compass and replace it with a magnet, inserting the magnet with the blue mark aligned with the current pressure setting. To adjust the valve setting, rotate the magnet until the blue mark aligns with the desired new setting. Remove the magnet and place it at least 60 centimeters away from the implantation site. Finally, confirm the new pressure setting by reinserting the compass into the locator and check that the arrow on the compass is pointing to the desired setting. Here, it is 70 millimeters of water. Unlocking the rotor's micromagnets within the Polaris valve may be difficult if the CSF is especially viscous or contains debris, or if locating the center of the valve is imprecise. The adjustment steps are mostly identical to the standard method, only the magnet manipulation differs. In these situations, performing multiple backwards and forwards movements of the magnet inside the locator along the axis of the implanted valve rotor can facilitate the unlocking of these micromagnets. Then, follow the steps of the standard adjustment method, always finishing by confirming the new pressure setting with the compass. In some cases, the connectors can be difficult to locate, which can make it difficult to accurately position the locator. In these situations, the stop method will help you position the instruments accurately in relation to the implanted valve actual axis. Position the locator again over the implanted valve with the direction of flow arrow properly oriented and center it using the compass. The compass will indicate the apparent current pressure setting of the valve. Because this scenario involves an implanted valve whose exact flow orientation axis is uncertain, the apparent current pressure setting may not be the actual pressure setting. The stop method will eliminate this uncertainty. Insert the magnet into the locator in the axis of the apparent current pressure setting and rotate the magnet to either extreme pressure setting position, lowest or highest, and exceed that position by 2 clicks further. Remove the magnet. Reinsert the compass. The compass will confirm the extreme setting low or high. Using this extreme position as a known starting point, the adjustment can now be performed following the standard adjustment method.